The anti-ice controls and indicators are located on the overhead panel. Ice is detected by a single sensor located on the right side of the forward fuselage. An icing light illuminates, accompanied by the associated ICAS message, when ice is detected. The icing light will extinguish, and the ICAS message will change when ice is no longer detected. Now let's discuss engine anti-ice. Engine anti-ice utilizes bleed air to heat the engine cowl leading edge. Engine anti-ice can be used on the ground and in flight. The engine bleed valve is located before the engine anti-ice valve. This allows a single bleed air source to provide engine anti-icing. Selecting the engine anti-ice switch to on allows bleed air pressure to open the anti-ice valve and heat the cowl leading edge. If one engine bleed source is inoperative, the isolation valve must be open to anti-ice that engine. If the engine anti-ice valve does not open when selected on, a valve light and ICAS message will indicate the disagreement. Also, if the switch is off, the valve light and ICAS message indicates that the valve is still open. When engine anti-ice is on, continuous ignition is automatically supplied to that engine if the respective start selector is in the auto position. Engine anti-ice operation is indicated by thermal anti-ice annunciators on the N1 indicators. During anti-ice operation, the maximum N1 and EPR limits are automatically corrected for the additional bleed requirements. A minimum N1 reference bug is displayed when operating on a single bleed source. The anti-ice annunciation and reference bug will turn amber if engine thrust drops below the minimum N1 bug. Engine thrust should be maintained at or above the bug to ensure adequate anti-icing. Now let's discuss wing anti-ice. Wing anti-ice utilizes bleed air to heat the leading edge of the wings. The first 3 leading edge slats outboard of the engine are anti-iced. Wing anti-ice is controlled by a single switch. Selecting the wing anti-ice switch on allows bleed air pressure to open the anti-ice valves and heat the wing leading edges. When the wing anti-ice valves are open, bleed air corrections are automatic. If the wing anti-ice is turned on or off and a wing valve does not respond, the valve light and associated ICAS message will illuminate. If a landing is made with the wing anti-ice operating, the valve will automatically close on touchdown, as indicated by the valve lights and ICAS messages. On the ground, the wing anti-ice system will not operate because of the air-ground sensor. Now try a few questions. Now let's discuss probe heat. Probe heat is a fully automatic system that includes pitot-static probes, total air temperature, and angle of attack sensors. Power to the electrically heated probes is applied any time an engine is running. Probe heat lights are located on the overhead panel. The probe heat lights are normally illuminated prior to engine start and should extinguish when either engine is started. A probe light will illuminate, accompanied by the associated ICAS message, when the respective probe heat fails. If more than one probe is not receiving power, the message probe heat replaces the individual probe heat messages. Now let's discuss window heat. The windshields are electrically heated for anti-fogging and anti-icing. The side windows are heated for anti-fogging only. In addition to electrical window heat, conditioned air is vented from the top of the forward windows. This air flows across the inside surface of the window to provide anti-fogging. The anti-fogging airflow takes place continuously and is independent of window heat. Window heat controls and indicators are located on the overhead panel. When the window heat switches are on, the windshields are continuously heated. The left side and right side switches control the respective side windows. The left forward and right forward switches control the respective forward windows. The inop lights illuminate when the respective switches are selected off. The inop light also illuminates if there is a fault or an overheat condition during window heat operation. The condition is also indicated by the respective ICAS message. In addition, power to the window is automatically removed. The system can be reset by cycling the affected window heat switch to off, then back to on. If the inop light extinguishes, the system has been reset with power restored to the window. If the inop light does not extinguish after the switch has been reset, a system fault exists. A window heat message will replace the individual window message when more than one inop light is illuminated. Now let's discuss rain removal. Controls for the rain repellent and windshield wipers are located on the overhead panel. A 3-position windshield wiper switch provides 2 speeds, low and high. The off position stops and parks the wipers. Now let's discuss 767 differences. On the 767, The engine bleed valve is located downstream from the cowl anti-ice valve. The thermal anti-ice annunciators are located directly below the N1 indicators. Anti-ice reference bugs also appear on the N1 indicators. If the wing anti-ice switch is on, after landing, the wing valves automatically close. However, the valve disagreement lights will not illuminate. The 767ER ice detection system has two ice sensors. Wing and engine anti-ice switches are controlled by 3-position rotary switches. If the wing or engine anti-ice system is off and ice is detected, the icing light illuminates and the associated ICAS message appears. The icing light will not illuminate during automatic operation. The auto position commands the engine and wing anti-ice valves to open and close automatically. However, the auto mode is inhibited on the ground. If a fault is detected in both ice sensors, the ice detector light illuminates and the associated ICAS message is displayed.